Now the functions of hemoglobin. After heme synthesis, the hemoglobin synthesis, the hemoglobin has now been formed, and now we are proceeding towards the functions of the hemoglobin. Hemoglobin is an oxygen carrier, very basic, very important function. And oxyhemoglobin is formed during physiological respiration when oxygen binds to the heme, and hemoglobin carries the oxygen to the red blood cells. This process occurs in the pulmonary capillaries adjacent to the alveoli. Alveoli is supplied with the capillaries. In the capillaries, hemoglobin is there, and this hemoglobin binds with the inspired oxygen, that is the oxygen which you inhale during respiration. The oxygen travels through the blood and reaches the cells where it is utilized. Here you can see hemoglobin is there. Now the oxygen from the lungs you just inhaled, this oxygen it binds to the hemoglobin and then it is carried to the tissues, and in the tissues this oxygen is released. Here you can see that the oxygen it is provided by the lung capillary which you has inhaled, and it combines within the lung cell, within the RBCs of the blood which is present in the lungs, because lungs are the well of oxygen. वो एक कुआं है, उसके अंदर सारी inspired oxygen होती है. So this oxyhemoglobin then goes to the tissues, and in the tissues it is decomposed into oxygen, and this oxygen is supplied to your tissue cell. This is the tissue cell. So this oxygen is supplied to the tissue cell. What happened in the first step? You just take in oxygen, you inhaled oxygen. Oxygen combined with the hemoglobin which was present in the lung capillary, and then this oxyhemoglobin is carried to the tissues. Now in the tissue cells, this oxygen will not be released. In the tissue cells, this oxygen will not be released until hemoglobin it finds any other companion. अभी तक तो उसने ऑक्सीजन के साथ दोस्ती की हुई थी ना, अब जब वो ऑक्सीजन को रिलीज करेगा तो उसको एक दूसरा दोस्त चाहिए होगा, एंड दिस इज द हाइड्रोजन आयंस. अब देखो कितना यहाँ पे गिव एंड टेक हो रहा है. Tissue cells, they are utilizing the oxygen, and in turn they are providing the hydrogen ions. ठीक है, किस तरह से? क्योंकि टिश्यू मेटाबॉलिज्म इट प्रोड्यूसेस कार्बन डाइऑक्साइड. दिस कार्बन डाइऑक्साइड इज कैरिड थ्रू प्लाज्मा to the tissues, and then this carbon dioxide is transported, and then the carbon dioxide is combined with water to form carbonic acid. This carbonic acid is then decomposed into bicarbonate and the hydrogen ion. This hydrogen ion then combined with the hemoglobin, and this hemoglobin forms the reduced hemoglobin. This bicarbonate and the hemoglobin both are carried to the lungs. In the lungs, RBC hydrogen ion from the reduced hemoglobin, they combine with the bicarbonate, and they form the carbonic acid. This carbonic acid is decomposed into carbon dioxide and water, and you expire the carbon dioxide through the lungs. So you inhaled oxygen in the capillaries of the lungs, in the hemoglobin, because you inhaled oxygen, the oxygen it diffuses and combines with the hemoglobin which is present in the lung capillaries. It is carried to the tissues. Oxyhemoglobin is carried to the tissues. In the tissues, it will release oxygen, but it will not release oxygen unless it finds another companion. What is the other companion? Hydrogen ions. The tissue cells, they provide carbon dioxide. This carbon dioxide combines with the water. It forms a carbonic acid. This carbonic acid is decomposed into bicarbonate and the hydrogen ions. And these hydrogen ions then combine with the hemoglobin to form reduced hemoglobin. So as soon as the hemoglobin, it gets the hydrogen ion, its new friend, it will quickly release the oxygen to the tissues. These both the things, bicarbonate and reduced hemoglobin, they are carried to the lungs, and in the lungs, hydrogen combines with the bicarbonate, forms carbonic acid, carbon dioxide is formed. This carbon dioxide is expired through the lungs, and now the hemoglobin is ready for combining more oxygen. Deoxygenated hemoglobin. Deoxygenated hemoglobin is the form of hemoglobin without oxygen. Oxygen is not bonded to the hemoglobin. And the difference between the oxygenated and deoxygenated hemoglobin measures the amount of oxygen in the patient's blood by the instrument known as pulse oximeter. You just put the finger in the pulse oximeter and it will gives you the oxygen saturation. That it will gives you the pulse rate as well. It will gives you the oxygen saturation. The difference also accounts for the presentation of cyanosis. Cyanosis is developed during tissue hypoxia, that is, oxygen is not present. Oxygen saturation is less, and in this condition the skin, it takes the blue to purplish color. If you see some palm of some patients, you can note the color change, and this is basically due to the oxygen deficiency. Heme iron, you know very well that heme is the site of oxygen uptake and release. Ferrihemoglobin, methemoglobin cannot bind oxygen, and thus iron must exist in the ferrous state to bind oxygen. One thing here you should remember, it can come in the MCQ. The oxygen combining capacity, it is directly proportional to the hemoglobin concentration, and it's not related with the number of RBCs. It depends upon the hemoglobin concentration. The more hemoglobin, the more will be the oxygen carrying capacity. Here you can see oxygen is binded to the iron, and this oxyhemoglobin will be carried to the tissues, and in the tissues this oxygen is unloaded. When oxygen binds to the iron of the hemoglobin, you can see a planar structure is there, whereas if oxygen is not there, then the heme is in the form of the tomb structure. Iron combines with oxygen and give it a red color. So basically the red color of blood is due to the combination of iron with oxygen. It also carries carbon dioxide from tissues to the lungs. Carbon dioxide can enter red blood cell and bind the hemoglobin. When carbon dioxide binds to hemoglobin, a molecule called carbaminohemoglobin is formed. When the partial pressure of oxygen in the lungs and tissue is low, that is, oxygen concentration is low, oxygen amount is low, obviously the saturation of hemoglobin is decreased. Oxygen is low, hemoglobin will not bind with the oxygen, And in this way, the more carbon dioxide can be transported in the blood as carbaminohemoglobin. When hemoglobin is in the reduced form, it becomes easier for carbon dioxide to bind the peptide unit, forming carbaminohemoglobin. Now you see a very important thing about the carbaminohemoglobin. Carbon dioxide, it does not binds with the iron of heme. This can come in the one correct answer. But it binds with the peptide subunit, forming the carbaminohemoglobin. Here you can see carbon dioxide has bounded to the protein chain. It is not bounded to the heme iron, whereas oxygen you can see here, it is bounded to the heme iron. Now you see the carbon dioxide, it is present in three forms. Protein bounded form, we have just seen that it is bounded to the protein chain. Chemically modified form, you can see here the carbon dioxide is converted to bicarbonate, and this is the modified form of carbon dioxide. So when the bicarbonate passes out of the cell, as we have seen in the last slide, then the chloride moves in. This is known as the chloride shift. And some of the carbon dioxide during the transport is also dissolved in plasma. So 40, 10 plus 30, 40, and then the 60%. It means that large part of the carbon dioxide is chemically modified to bicarbonate. Carbon dioxide, we have just seen that carbon dioxide, where it binds to the protein chain, and it has no competition with oxygen for the iron binding position, but it is bounded to the protein chains of the structure. Carbon monoxide, that is also it combines with the hemoglobin and it forms the carboxyhemoglobin, and it gives a cherry red color. So it is cherry red, and it is formed when carbon monoxide binds to hemoglobin or displaces oxygen from the oxyhemoglobin. Hemoglobin has greater affinity for carbon monoxide than oxygen, and once carbon monoxide is removed from inspired air, oxyhemoglobin is reformed. Consciousness is not lost until half of the oxyhemoglobin has been replaced by carboxy form. Half of the hemoglobin, right? If half remains in the oxyhemoglobin form and half in the carboxyhemoglobin form, the consciousness will not be lost by carbon monoxide poisoning. Unless more than half of the hemoglobin, it is occupied by the carbon monoxide. Here you can see when the carbon monoxide, it binds with the hemoglobin, then the compound, it cannot bind oxygen. Hemoglobin carries oxygen and carbon dioxide. You can see here, and when this carbon monoxide comes, it displaces both. It displaces oxygen as well as carbon dioxide. It means that carbon monoxide has greater affinity for hemoglobin as compared to oxygen and carbon dioxide. As soon as carbon monoxide comes, it displaces, you can see here, the oxygen in light blue and the carbon dioxide in that, oxygen and carbon dioxide in the light blue and the dark blue, and both of them, they are displaced. Both of them they are displaced, this indicating the difference in color. One is carbon dioxide and one is oxygen. So both of these are displaced whenever carbon monoxide it comes to bind with the hemoglobin. Hemoglobin from the lungs, it combines with oxygen. I told you that lungs is a well of oxygen. Hemoglobin combines with the oxygen, and the oxyhemoglobin it goes to various tissues, and carbon dioxide is produced. You have seen how carbon dioxide is produced. Bicarbonate combines with the hydrogen ion from the reduced hemoglobin, and then carbonic acid is formed, and this carbonic acid is decomposed into carbon dioxide and water, and this carbon dioxide is carried to the lungs for expiration. How carbon dioxide is formed? Oxyhemoglobin, when it goes to the tissues, then from the tissues, hydrogen combines with the hemoglobin, HHB. HHB is carried to the lungs. In the lungs, this is converted by the hydrogen ion and the bicarbonate. Bicarbonate is also carried to the lungs, and the HHB is also carried to the lungs. Just see the last slide or the previous slide, right? So hydrogen HHB is carried to the lungs, and bicarbonate is also carried to the lungs. In the lungs, hydrogen from hemoglobin is removed, and it combines with the bicarbonate to form the carbonic acid. This carbonic acid is decomposed into carbon dioxide and water, and carbon dioxide is removed through the lungs. And now the hemoglobin is ready for reloading oxygen for carrying to the tissues. Nitric oxide. Nitric oxide is transported by hemoglobin by binding to the ferric form of iron, when hemoglobin releases oxygen from its U side. So which form of iron binds? Ferric form. Nitric oxide, it binds with the ferric form of iron. Nitric oxide can also be transported by binding to amino acid cysteine. It means that nitric oxide can be transported in two ways: binding with the ferric form of iron as well as binding to the protein chain, and especially with the amino acid cysteine, which is present in the globin protein, to form S-Nitrosothiol, which dissociate into free nitric oxide and thiol again. The nitric oxide. Now, what is the function of nitric oxide transport? The nitric oxide transport to peripheral tissues is hypothesized to assist oxygen transport, because nitric oxide has vasodilatory effect, and in this way it assists the transport of oxygen. It helps the transport of oxygen even where the oxygen level is low, to the tissues where the oxygen level are low, because it produces dilation, vasodilation. That is the dilation of the vessels, blood vessels. It has a vasodilatory effect, and in this case the oxygen can be transported very easily. So there is a hemoglobin nitric oxide partnership. Nitric oxide is a vasodilator that plays a role in blood pressure regulation. Obviously, several drugs are also vasodilation. Through the vasodilation, they control the blood pressure. Hemoglobin is a vasoconstrictor, and nitric oxide Scavenging heme destroys nitric oxide. Heme destroys nitric oxide. Hemoglobin is a vasoconstrictor. However, as oxygen binds to hemoglobin, whenever oxygen binds to hemoglobin, देखो नाइट्रिक ऑक्साइड के पास दो चॉइसेस है, वो फेरिक फॉर्म ऑफ आयरन से भी बाइंड कर सकती है और वो प्रोटीन चेन से भी बाइंड कर सकती है, सिस्टीन अमाइनो एसिड सिस्टीन से भी बाइंड कर सकती है. सो एज ऑक्सीजन बाइंड्स टू द हीमोग्लोबिन, तो नाइट्रिक ऑक्साइड क्या करती है, नाइट्रिक ऑक्साइड बाइंड्स टू अमाइनो एसिड सिस्टीन ऑन द हीमोग्लोबिन, and bounded nitric oxide is protected from degradation by Heme's iron. In this way, देखो ये इसने कितनी चालाकी की है कि ग्लोबिन के साथ बाइंड हुई है, हीम के साथ नहीं बाइंड हुई है, बिकॉज हीम तो नाइट्रिक ऑक्साइड को डिस्ट्रॉय कर देता. So it binds with the amino acid cysteine, it binds with the protein chain, and in this way it is protected from destroy. The nitric oxide is released as oxygen is unloaded, causing the vasodilation. This shows there is a partnership between nitric oxide and oxygen, because as the nitric oxide is released, oxygen is unloaded. Nitric oxide causes vasodilation and it assists the oxygen in the tissues. As deoxygenated hemoglobin picks up carbon dioxide, it also binds nitric oxide and carries these gases to the lungs for unloading. Very important function of nitric oxide. As deoxygenated hemoglobin picks up carbon dioxide, right? Deoxygenated hemoglobin, oxygen-free hemoglobin, when binds with carbon dioxide, then it also binds nitric oxide and carries these gases to the lungs. So not only what are the three important functions of nitric oxide? Vasodilation, it affects the transport of oxygen due to its vasodilatory effect. It transports carbon dioxide to the lungs, and in this way the carbon dioxide can be transported to the lungs very easily. This you can get in one incorrect answer. Functions of nitric oxide include all except. What are the functions? Number 1, vasodilatory effect, facilitate the transport of oxygen to the tissues and facilitate the transport of carbon dioxide to the lungs.